Live from our Lakeview studio in the Windy City. Welcome to the Chicago Python lunch break. My name is Ali Sivji. I am one of the organizers of Chicago Python, and I'm going to be your host for this afternoon's event. It's our last event of the year. How exciting has this year been? We're going to end it on a high note. All right, so let me get my screen shared, and looks like we are good. All right, so today is our Python lunch break. As I mentioned, it's our last event of the year. Before we get started with all of that, I do want to make everybody aware of our code of conduct. Anytime you're interacting in a Chippy space, this could be in our YouTube chat, in our YouTube comments down below, you have to sort of abide by the rules of the Chippy code of conduct. There's more information on our websites. What is Chippy? Chippy, or the Chicago Python Users Group, is a Python-focused community that was started back in 2003. We've grown from our humble beginnings, where we only had a few members, and we can fit everybody into a small conference room or into the back of one of the Chicago bars. Now we're one of the largest Python communities in the world. We have over 6,000 members on Meetup. On top of our monthly meeting, which happens on the second Thursday of every month, we have special interest groups that focus in on more niche areas of Python. We have one for finance, data, web dev / DevOps. Our most active one is for algorithms and data structures. And here folks meet and work on those HackerRank or LeetCode type of problems. So if you're looking for a job and you got an interview, really recommend you'll go check it out. What's going on for upcoming events? You know what? Let's not talk about it. It's the end for Chippy for this event and for 2020. Check us out. I think we have an event on like January 4th, but check it out in 2021. I'll worry about that in January. Where can you find us? We have a very active Slack community, over 2,000 folks talking about various things about Python that are happening both in the wider ecosystem, as well as things that we are doing at Chicago Python. Currently, it's the Advent of Code season. Every day during the Advent season, there's a programming challenge released at midnight Eastern time. And a few folks in our community are working on those challenges and just communicating and sort of sharing their experience in the Advent of Code channel. You have a few days to get started and to catch up. Really recommend y'all go do that. So it's been a lot of fun. Let's see what else. If you're on Twitter, we are also on Twitter. Give us a follow at Chicago Python. All of this information plus a lot more is available on our website, and that is chippy.org. All right, today we have a fantastic talk by Dmitry Dygalo. It's going to be about a library called Schemathesis, and that's going to help you do effective API testing. Before we bring him on, I just want to make y'all aware that we are going to be doing a Q&A section or session at the end of this talk. So if you have questions or sort of just want to interact amongst the community, you can do that right there in our live chat. All right, let me close this down and bring Dmitry onto the live stream.
Hello.
Hey, Dmitry, how's it going?
Hello. Everything is good. Yeah, how's it going for you?
Things are good. It's snowing in Chicago. Whereabouts are you calling from?
I'm calling from Prague, from the Czech Republic, and we don't have any snow at all.
Okay, well, that's unfortunate.
Yeah, it's warm.
Yeah, it's just beautiful outside. But yeah, you are our second speaker from Prague, so it sort of feels like one of our Chicago Python sister cities. But can you please introduce yourselves to our audience?
Yes, sure. I just have, I work usually with Python and do consulting in area of web development and like software testing. Mostly I work like with Python related projects and doing a lot of open source work. So yeah, for like, I don't know, last 10 years or so. And initially I learned information security. So it's my background.
Okay, awesome. So you've been doing Python for a while. How did you first get into it?
It's basically when I had classes in my university, it's basically it was really convenient to use Python to solve some cryptography or any other theoretical things. So I just got used to it, and just it's like grew a lot in this direction.
I always think it's like such a clean language. It's easy to prototype new ideas. You can do it so quickly. We were sort of talking about this before we went live. In Chicago, we're dealing with the effects of sheltering in place. The second round of lockdowns is almost over, just in time for another spike probably going to happen around New Year's Eve, just sort of just the way the city seems to work. But can you talk a little bit about how you've dealt with sheltering in place?
Yes, actually, we had just like the second lockdown went off a few days ago, and yes, it's been hard to keep working and keep being productive. But like during this year of like various lockdowns, I tried Dungeons and Dragons. So I play with my friends over network, and yeah, it goes pretty well. And we are kind of helping each other through through story and everything like that. So it helps.
Yeah, for sure. It's always good to have that sense of community wherever you can definitely find it. That's it for all my questions. Are you ready to get started with your talk?
Yes.
All right, let me share your screen. Dmitry, please take it away.
Yeah. Hi everybody. Today I'm going to talk about effective API testing, and as I already introduced myself, you can find me with Stranger 6667 almost everywhere if you need to. And like, I want to start with consequences of what happens if you don't test your API effectively. Like, first of all, it may lead to logical errors, like when the input requirements are incorrect. So, for example, your user can, for example, top up for a negative amount of money. Or if your API documentation is outdated, it can be a huge source of confusion. Like teamwork is out of sync, things become harder and harder to grasp what's going on. Also, like we often miss security issues there. Last year's research from Microsoft showed at least 4 security properties that REST API should hold, but of course there are more of them. For example, if your input validation doesn't work well, it's possible to create some payload that will slow your application down, and eventually it could be denial of service, as one example. And of course, like, you can crash your application on unexpected input, which shouldn't happen. And in general, it goes toward a lot of waste time, and it creates really high cognitive load on people that is completely unnecessary. And of course, there are possible financial losses. But how did we get there? First of all, like, modern systems are complex, and you need to balance requirements on complexity or resources and basically time. So, but in the end, like, if something can go wrong, it will go wrong. The Murphy's law is working. But what usually I see as common solutions here. Like, I often hear, like, let's add more people. Let's hire another group of testers. I think it's kind of very superficial way to solve the problem. And hiring more people increases the amount of communication. And Fred Brooks formulated it a long time ago. What one programmer can do in 1 month, 2 programmers can do in 2 months. So it's some kind of not working well. Also, we can try overtime. Let's work in the evening and make some crunch. We have a release soon. Like, the law of diminishing returns says that basically, like, the more you work, the less productive you are. And even worse, it can lead to burnout. And it's really, really bad. So it doesn't work. Another solution that can be possible, so let's add more powerful machine or something like that, better hardware. But in this case, you need to exactly understand why do you need it instead of blindly buying better hardware. So I would say that these solutions, of course, they might work as a short-term things, but generally they can have negative consequences in the long term. What else? We often formalize testing. It's great, of course. Like, we have like a lot of structure in our test suites. We have like processes, everything. It's great. But still, we are really good in forgetting things. Like, we still are limited by our imagination. And like, next step, it's better. Like, let's add some automation. Let's take, for example, our API schema and generate some Python code. For example, we have connection framework that works this way. Or we can work other way around. We can generate API schemas like FastAPI does, and many other frameworks. So yeah, synchronization is great. No questions asked. But usually it's really limited in some way. For example, FastAPI doesn't generate valid OpenAPI schemas in all cases. So it happens. And almost all tools have some limitations. So I think that it's better to start from the design stage. So we prevent actually all the not all, but we try to prevent problems from the beginning. And I think that our time is the most valuable resource. So we need to reduce costs, especially time-wise. And it's great to automate everything which is kind of connected to costs. So the first thing I would like to mention is a good API is hard to misuse. It's like the main design principle that I ask you to follow or just keep in mind. So let's start from API schemas and how we store them. YAML is kind of the default choice for many things. Like Ansible, it uses YAML, and many other things like OpenAPI uses YAML. Their documentation contains mostly YAML examples. But let's check. For example, we have a list of countries here. Pretty simple, but if you will parse it with Python, like the last entry is false for some reason. It's so-called the Norway problem, because YAML has a lot of corner cases when it parses things not in the way they are expected. Yeah, for example, none is also parsed, not like string. So we need to explicitly escape strings. Generally, I would say that it might lead to really like nasty problems that are really hard to debug, especially if you don't have any validation or stuff like that. This tooling, it's okay, pretty much, but still, we have JSON. Is simple and pretty much reliable and faster to parse, if it matters, of course, of your case. So another thing that we can prevent on the design stage, for example, typos. We have really a lot of situations when we just when typos are going unnoticed completely. Let's see an example. Here we have a schema that has exactly one property called success. And if you pass success true, everything is okay. But if we make a typo, like we forgot the last character, it also passes. But we can balance our strictness and flexibility and, for example, add the success field to the required list. Or if it's not really required, we can use it passes. It doesn't pass the validation. And if it's not really required, we can use additional properties. So we can kind of balance strictness and flexibility so these schemas are more error-proof. So I think that another common thing, another common source of problems are regular expressions. Of course, it depends on exact usage, but let's check this simple example. Let's say we have a pattern of 2 digits, simple enough, and like 42, everything is passes. But let's say that our user comes from Emirates, maybe, and uses like local Unicode digits. It also passes. You might expect it, but sometimes you don't expect it. For example, if you validate credit cards, you use the Loon algorithm, and it might expect strings, not their digits. So it depends, but it might be not what you expect. And the simple solution would be just use regular digits and a simpler regular expression, which allows only regular digits, non-Unicode. Generally, I would like to note that regular expressions have a really bad reputation. For example, you can maybe you remember the last year Cloudflare outage, which was caused by a regular expression. And for example, this one, seemingly simple, it computes for like 90 seconds on my machine. And I believe that a longer string will never finish. So please, if you can express your intentions without regular expressions, please go ahead and use some alternative ways. If you need like minimum length, maximum length, just use the corresponding JSON schema keywords. It's simpler, faster. Or use engines without look around and back reference features, like the one from Rust, like regex crate, or the one from Google. I don't remember the name, but there are ports for like Python. So keep it in mind. Generally, I would say that on the design stage, you can think about using a simpler serialization formats, and you can balance strictness, flexibility, so your schema is more reliable. And of course, regular expressions, use it with precautions. But let's take a look at how we actually test things. For example, let's check if a plus b is equal to b plus a. So a regular example-based approach would look like this. So we have a test with 2 arguments, and we just run assert. Okay, it's simple enough. And we spy test, we usually use something like that. Mark, parameterize, we specify these arguments, and we provide an explicit list of examples. So yeah, it's kind of okay. It's really straightforward. Just put more things there and we test them. But again, we need to keep in mind all the corner cases to test everything properly. So human factor still applies. And yeah, if you have a lot of entries there, at some point it's really hard to maintain. You may think about some code generation or some tooling around it, and it still adds maintenance cost. And there is another approach to testing things called property-based testing. And in Python, you usually use hypothesis. Okay, we can use the same test body, but let's use hypothesis to test it. So usually you define some strategy, so-called, which basically defines what type of input your test requires. And we can define numbers as like integers or floats. And yeah, it looks really like simple. So you just defined what A is and what B is. So then you can run it with PyTest as usual. And at this point, hypothesis, like in less than a second, it shows that actually commutativity doesn't hold for, it holds only for real numbers. Not a number doesn't work. So actually, I think that it's really important to have really high input variation here. And it has shrinking. So your examples will be minimized in the way that you will have really minimal thing that you need to put into your test to make it fail. And it's really useful because sometimes you have really big data chunks that are really hard to grasp and understand what actually causes the problem. And another useful thing is that you actually learn more about your code and what actual restrictions are and like how it should work, because hypothesis examines not all, but many more possibilities that you can think of usually. So it still requires some guidance there. You need to define all these strategies, but yeah, I think that these two approaches, they complement each other, and it's really important to combine them to make things effective. But let's talk about APIs again. Still, we have some API properties, right? We probably can think about a few of them, like it should not fail, like the bare minimum. You should not have any unhandled errors. You should handle all your inputs in a graceful way, and like everything that matches your schema should be accepted, and vice versa, which like usually doesn't work like this, but it's like a useful assumption to start with. Yeah, because we have like something else than only like the schema restrictions. Then we can think that, okay, responses should match their definitions. Yeah, sure. And all examples should work. Or maybe that all responses should take less than 500 milliseconds or so. So there are a lot of assumptions that we actually make in our regular tests, but they're kind of implicit. So, some time ago, I started this project called Schemathesis, and it combines API schemas with property-based testing. And it works pretty like, the process is like this. Let's say we have a post users endpoint. And let's imagine that it accepts some simple payload like an object with one field called name and some string there. Okay, then Schemathesis takes this API schema, it creates some hypothesis strategy, then it makes a lot of requests and validates responses. So a simple, like we support mostly open API versions. except maybe the latest one. And we support GraphQL as well, though it's limited. But the only thing you actually need is a valid API schema. Like most of the time, even malformed schemas will work because Schemathesis will try to filter things that it can do, and it will run tests when it's possible, and will raise some errors when schemas are malformed. So here is a simple example of how it could be used. It's really similar to PyTest in some way. The first thing that we need to do is load our API schema, and you can do it like with a network request. You can use files, you can just pass a dictionary, whatever. There are like 6 or 7 different ways to do so that are built in. Then it's really similar to the PyTest parameterized decorator. So every Schemathesis test should accept this case fixture, and then you just call a simple function, a simple method on this object, and it will run all the things that I mentioned before. So, and if it will find any error, you will see something like that, which kind of corresponds to the regular PyTest output in some way. You will see your endpoint with a failure, then some information regarding the stack trace and everything related to it, and then some message about, oh, we have a failure here, or we have, I don't know, schema does not conform to its definition. Here's the payload we received, and here the code you can run to reproduce it. There are, of course, like more details, and usually it's pretty verbose, sometimes unnecessarily verbose, but yeah, it boils down to this. Then unit tests are regularly, they run fast. And you can really customize a lot of things and integrate to your regular PyTest-based or unit test-based test suites. So let's see an example of how it could be customized. Let's say we have an API where we want to reset a password of some user. Yeah, sure, we have a regular test function. So the first step, of course, is to load the schema, as in the previous example, but then we just add this parameterized decorator with the case fixture, and we specify, okay, we need to generate tests only for this endpoint. Sure, no problem. But we also have Python fixtures. Would it work? Yeah, sure, no problem. Here we have the user fixture, and maybe some hypothesis strategies like this. Maybe we can generate Boolean. Yeah, sure. Here we generate a Boolean value, and if it's true, then we can just replace some case parameter, some case attribute with, I don't know, generated token or whatever. So you can basically use whatever you already have in your test suite. Your fixtures will work automatically. Your hypothesis strategies will work. So you can basically just add it to this test and just call the API and validate the response. No problem. Here is an example of what data could be generated. Usually it contains really cryptic structures that fit the schema. But yeah, it allows you to test various really different inputs. And besides usual unit tests, we have integration tests. Let's say we have our post users endpoint. and it returns some ID of the newly created user. Sure. Then we have another endpoint where we can get some information about the user by ID. And then OpenAPI provides a really nice approach to describe connections between different operations. It's called OpenAPI links. So if you check our schema for this endpoint, where we create our users, then all that we need to do is basically say, for when the response is 201, let's add a connection to a different endpoint with some arbitrary name. We can define multiple connections to the same endpoint if we want to, by different names, and we specify what is the target operation we would like to connect to, and we define a list of parameters. And this operation defines only one parameter called user ID, and what we need to do is basically take the response body and extract the ID value from it. It uses the OpenAPI runtime expression syntax, and it's completely supported by Schemathesis. So in the end, we will have our post request with some response here, and Schemathesis will know that, okay, we can make another request to some another endpoint and use this 42 as a parameter. And in the end, you will have a lot of completely random API sequences that will include different calls, and these connections will be used there. So from the coding perspective, it's based on the hypothesis state machines. The state machine is basically how you describe a single API sequence, and it basically describes various transitions between different API endpoints and what can be used, what cannot be used. So then it follows the regular process from hypothesis, and you can run it with PyTest or unit test. And it's pretty much customizable. You can define whatever you want on this state machine. You can define some setup. For example, in the beginning, you can log into your API or create a user and store some authorization headers and use it on each call. And then you can have some cleanup, remove the user, make some logout or whatever you need to do. And all the generated sequences will have these steps. Then if it finds something, you will see similar output that I showed you before. You will have some information about what actually crashed, some response payload, and code to reproduce the problem. And usually it's super verbose because these payloads are usually big, but you can just copy paste all the code provided by the output of our PyTest plugin, basically, and just reproduce the issue. So we have pretty much a lot of features, and you can generate everything you want to. You can adjust any component of the of this case object. You can adjust your query, path parameters, headers, whatever, body. So you can add your own hypothesis strategies and use some extensions to anything. Then we have explicit examples testing. Like if you're familiar with Dread, we do the same. We basically test all the explicit examples that are defined on your schema. And you don't have to actually specify everything. Maybe you missed some property in some object. It's okay. Schemathesis will fill all the gaps. So even partial examples will work. We have a command line interface, and the Docker image, you can run it from whatever you want to. You can replicate your failures with VCR style cassettes, so you can record and replay things there. And if you have a Python project, you can integrate it with Schemathesis directly if it supports WSGI or ASCII. So you can leave out the network layer completely and run your tests directly, which is usually much faster. But as I said, the data that Schemathesis generates, it matches the schema. So we have only positive testing currently, but there is already almost already pull request that introduces negative testing. So it will be there like in few weeks. Then another point that we introduce, I believe this week, is data generation for arbitrary media types. For example, if you have an API that accepts a CSV file, sure, no problem, it could be generated. XML, yeah, no problem. And if your media type is not supported directly, you can provide a custom hypothesis strategy that will generate your data type, no problem. For example, I believe that there is already a strategy for generation of images like JPEGs and stuff. So it should be easy to integrate to Schemathesis. So it will be automatically used when an endpoint requires this media type. Then, yeah, often the output is overly verbose, and the signal to noise ratio is not really nice. So I would like to redesign it and improve the usability of this tool. Also, the most common request is to have an interactive documentation, so it's also in the works. And some time ago, Zach Hetfelders from Hypothesis, he's a Hypothesis core dev, reached me and asked if I'm interested in making an academic research on this matter. We are researching how effective is the how property-based testing is effective on regular APIs. So the main question for us that we would like to answer, is it effective at all or not? And my short answer is yes, but the longer version is it depends. It depends on your definition basically of effectiveness, what you would expect from these tests, what issues we would like to discover. For example, some companies are more interested in security issues than just regular crashes. For example, there is a tool called Fast Lightyear from Yelp, and they use it mostly for security issues rather than just crashes. And yeah, we have a list of around 170 projects. We will use 10 or 11 tools, and we have one supercomputer to run all our experiments. So they should be done somewhere in January, and we will try to find out whether property-based testing is effective or not. But like, an example from like my recent tries, I got a Flask application from GitHub. It has like 85 endpoints, Swagger 2.0 documentation, and Schemathesis was able to crash 80 of 85 endpoints in 5 minutes or so. So I assume it's effective, but how effective, we'll find out soon. If you have, by the way, if you have any project that you would like to test, so feel free to submit it. It would be really interesting to see how it performs. And of course, we have a lot of limitations. Usually it comes for complex schemas, but you don't have to worry unless you have more than 10 levels of nesting in your JSON payload. So it usually goes for really like tools that expect some complex configurations or so. Then we use only Python compatible regex syntax, which is some kind of like a limitation, and actually the standard defines a different regex syntax than Python's. For example, I believe that AWS uses Java compatible regular expressions, so their APIs are not compatible with testing by Schemathesis. Then we have a limited GraphQL support. It's available only in Python tests, not in our CLI, but still it works and it's able to find failures. Then what's next? Another point that I want to mention is hypothesis core itself. There are already efforts importing it to Rust. The old hypothesis core engine was written in Rust, but it worked only for Ruby. And there is an open pull request to resurrect it. And I hope that it will go well and we will have improvements in this area, because usually it's quite often when you can see performance issues during testing, and they are not on the network side and they are on the data generation side, because usually you have it's a multi-layer problem. You have JSON schema validation that is in Python, then you have JSON serialization, which is in Python, then you have hypothesis that is written in Python as well. And sometimes it's really slow. Again, I tried running Schemathesis on some big schemas. I believe it was, again, AWS or so. And it was kind of slow, but still, it was working. And we want to improve it. And it will be interesting to see how Schemathesis performs as a service, so we can integrate it in your CI. And I'm currently working on the project called schemathesis.io, where you can have some schema improvement recommendations. You can have much faster data generation, again, powered by Rust, because I already ported some parts. So yeah, it works faster, much faster. Also, as I mentioned, you need to use OpenAPI link syntax, but it's possible to infer them with machine learning or just by some, we can just infer them manually. So it will be also possible to test OpenAPI callbacks and irregular CI stuff, so you can use it in your service, no problem. So if you have any questions, please post them in the chat, because it's almost everything I got for today. And once again, a good API is hard to misuse. Property-based testing and web APIs work surprisingly well. Try out Schemathesis, and please, folks, support open source, support Hypothesis. We need your help. I would be really happy to collaborate with you. Here is a list of references, and I will submit slides. So you'll have them. Yep. Thank you.
Awesome, that was great. Can we please give Dmitry a round of applause in our chat? That was fantastic. I have a few questions while we wait for others to come in. So you were talking about some of these tests take a long time. Like, what's the average amount of time, like running? I know it really depends on the size of your API, and there's like all these other factors. But could you sort of just like ballpark what people should expect?
It's seconds, like tens of seconds. By default, we use the default settings from Hypothesis, which includes up to 100 generated examples. So usually it takes like tens of seconds, but you can increase the amount of tests like the Schemathesis will generate. So you can adjust it to your need. You can generate less, you can generate more. It's up to you, but usually it goes in like tens of seconds.
Okay, awesome. So this is something that you probably would want to incorporate into your CI pipeline at like pretty much every single run you want to do.
Yeah.
Okay.
Yeah, and it's another reason basically to improve the performance on the data generation side. So this is why I would like to push more Rust into it.
Yeah.
And yeah, build faster tooling here.
That makes a lot of sense. And just so that sort of leads me to one question. What kind of errors does the Schemathesis seem to find when it does find errors?
Okay, yeah. For example, that API with 85 endpoints, it found like, I believe, like around 8 different types of errors. This project was using raw SQL queries, so it found like few cases when there were no Postgres operators for some queries. Then it found like attribute errors when, I don't know, this branch wasn't tested at all, apparently. So it just was a type or something in the attribute name, but it wasn't tested. So it just found it. And then, yeah, like type errors when you convert integer, like you create an integer from a string. So yeah, it was possible to pass some weird values or so. Yeah, it can find anything actually. In my previous job, I found like also a performance-related issues when like your regular tests are running okay, everything is fine, but when Schemathesis generates things, like suddenly we got like not enough connections to the database in like 3 seconds. Like, okay, it's like definitely it's not ready to like production load. So it also can find these kind of denial of service attack vectors.
Yeah.
Like Hypothesis itself, it has a really nice feature called targeted testing, when you can specify some target towards which Schemathesis will adjust the data generation. And in our case, we can say, okay, please generate data that will more likely cause longer responses. So it will try to generate longer queries, etc., and it might find denial of service issues. For example, usually in our APIs we have limit or something like this. So it's like limits the amount of items it will output. One of the issues I found in my previous job was, again, it was too large number which caused like to read almost the whole table from the database, and it causes crashes just because of the size of the output.
So say for like a performance test, would that be something like you're running Schemathesis against like a staging instance of your environment? Like what was sort of like the workflow for that?
Yeah, staging definitely helps. Like the closer to your production you are, the better. Because if you have some production-like data in your database that you're working with in tests, then it definitely increases your chances to hit some problems. Yeah, the regular workflow I see usually is separate Docker container or like Docker Compose stack. So you just run everything, you like start Schemathesis, you see what happened. You load your data, but yeah, it should be like isolated as much as possible.
Okay, awesome. And so a lot of this involves having like a schema already good to go. So you have to have like Swagger docs or like Open API. There's sort of like a little bit of a difference there. Can you talk a little bit about, say you're at an organization that does not have all of these Swagger docs in place. What would you recommend as a process for folks trying to get up to speed on Swagger docs to implement a tool like Schemathesis?
Yeah, I would recommend using schema generation tools. Like for Flask, you have Flasker, you have API spec, you have for Django, I believe it's called Django Yask, yet another schema generator.
Yeah, I've used
so
that.
It's basically the baseline where you can start, and then you can see, okay, here are some responses, and here are some requests. And actually, I would like to implement a tool that will infer schemas from it automatically. So you can just run things, and yeah, it's a part of the workflow for schemathesis.io. When you have some schema recommendations, like you can generate some baseline, and then schemathesis.io will suggest you like change these, add these, it will work better with these, this stuff like that. So yeah, but the baseline is some schema generation tools.
Yeah, for sure. So before we do let you go, I did want to find out a little bit about when people want to get started with starting to use Schemathesis, what do you recommend their next step is?
I think like we still have a lot of examples in our documentation. And if you would like to continue with using Schemathesis, you can find some like extensions there or some like next steps in our docs. And I think you can start with just unit tests, just test your endpoints separately. Then you can start with integration tests. And these workflows are usually, they can go really complex. So the bare minimum is just run Schemathesis on what you have, and then you can adjust stuff and integrate more and more. Like integrate new media types and custom strategies for schemas.
Okay, great. And I know this is an open source project. I'm sure you're always looking for folks to help out. Can you shout out a couple of issues that you're looking for help in?
Yes. I believe they are marked in the in the issue tracker. They should be marked with like good first issue or something like that. At least I know that I marked them for Oktoberfest, and there are still something left. So there should be some issues.
Awesome. And if you're looking to get involved, check out their GitHub, and we'll post links down below in the comments after this video. Thanks so much for joining us. Can we please give Dmitry another round of applause in the chat? I'm just going to copy and paste my emojis. Before we let you go, is there anything you want to just give a shout out to?
Just I would say that, folks, we need your help in bringing the ecosystem forward. So please help out with Hypothesis, with Schemathesis. We have a lot of things to do. And I believe it will help everybody to get more effective API tests.
Awesome. And yeah, get these guys to write better code so you don't have to write this test code yourself. So I think that sounds like a perfectly great value add there.
Yes.
Well, thanks so much, Dmitry, for joining us, and we'll talk to you later.
Thank you, Ali. Yeah, thank you.
All right, so that was Dmitry talking about Schemathesis, which is a Python library he created to do property-based testing of APIs. I've been looking to get it incorporated into the APIs for the job I work right now, but it seems like our API documentation generation is not the best. So hopefully we can get there early next year. But yeah, very excited. It's gonna find us a lot of edge cases, and can't wait to actually have the computer test versus testing myself. All right, well, that's it for Chippy for this year. It's been an interesting 2020. Thanks for bearing with us as we figured out this online medium. It's been great. We've been active. We've been supporting each other. Advent of Code has been fun. A lot of great things I've been seeing in this community. Well, thanks everybody for joining us, and we'll see you next year in 2021. Take care.